All right, guys, I'm at my daughter's softball practice, and I thought there's not going to be a better time for me to get this done than right now. So I'm going to go ahead and give you the introduction for your kinematics video. Okay, kinematics are the equations that deal with motion. So anytime we're dealing with anything with motion, there's a good chance that we're going to use one of our kinematics throughout the entire year. So we have multiple kinematic equations. We have equations that solve for time, distance, velocity, acceleration. Sometimes we look at these things and we get kind of confused on which one to solve for, but what we need to do is we need to look at what do we know, what are our variables. So when we look at a problem, we want to go ahead and pull everything that we know out of it. We want to go ahead and write everything down. Okay, notice I'm saying write everything down. Okay, put it on your paper. Don't tell me that you plugged it in your calculator, because that doesn't do any good. Write it down. So have it written down, all your variables. Sometimes you're going to still be missing things. So then we need to start thinking, what do we know from the problem that maybe we actually have a variable for it, but it's just not actually something that is given to us. So maybe our car is at rest when it starts. Okay. Sometimes they don't tell you it's at rest, but saying the car gets going and finally hits this final speed. So if it's at rest, or if it kind of implies that it's at rest, you need to remember that it's zero. Okay? It gives you information, you just might not know it. So kinematics are kind of handy, but at the same time they're a little tricky when you first get started. So we want to take the time to make sure we know how to do the kinematics right, we do a good job with them, and then we have them written down so when we actually get going, it is something that we always have and will always be in our toolbox. Alright, let's go ahead and take a look at the kinematics that we have right now. Alright, our first kinematic is going to solve for velocity final. Now I know it says velocity 1, but what that is just saying it's the velocity that we're at next from our initial starting point of V0. In some other physics classes, sometimes you'll see velocity initial with a little I, and you'll see velocity final as the last one they're solving for, which would be in this case this one. But for what we're going to use is we're going to use like velocity 1, velocity 2, velocity 3 as we go on and on and on. Okay, now here's the basic equation, which is velocity final equals our velocity initial plus the acceleration times time. Okay, but we can solve for any of these variables in this equation if we can rearrange. Okay, it's very important. We have to be able to rearrange the equations. We don't want to write 8,000 different equations just to solve for the different things we're solving for when we have different variables. So learn this equation, put this in your notebook, and then we can solve for each one of these little variables by where we rotate, okay, how we solve for them. So that's pretty easy to solve. That's algebra 1. Again, we'll be working those problems, so you'll see lots of them. Write that down, equation number 1. All right, our second equation is going to be over distance. Okay, now so this is our distance final equals distance initial plus 1/2. Now this whole little part right here that's in parentheses, that's basically just our change in velocity. So sometimes you'll see it written as delta V. Okay, so don't freak out when you see delta V. Times our T. We'll see this equation again quite a bit. But we can solve for any of these variables: distance, distance initial, our velocity initial, our velocity final, or our time. Sometimes we'll also see this written so we can solve for change in distance. Those are all things that we can solve for. It's pretty awesome. All right, this equation on the surface, when you first start to look at it, kind of looks like that last equation. But we got a lot more stuff in here. We have our velocity initial, so we're going to be starting somewhere. We have a time, and then we have 1/2 AT squared. Okay, it's very important. Things that people screw up on usually is they forget to square this, or if they're solving for time, they forget to take the square root to actually solve for t and not t squared. Equation at first looks really, really gnarly because it's kind of long, but half the time, our initial distance is 0 because we're starting at a 0 point. So we can get rid of this part of the equation. Our velocity usually starts at 0. So we can get rid of this part of the equation. So usually what we're solving for most of the time is d1 equals 1/2 at squared. Okay. Most of the time we see that when we talk about free fall. So we're dropping an object. So when I say 1/2 at squared, usually your brain's going to automatically go straight to free fall. So this equation, 95% of the time for what we do, is going to be written this way. All right, final kinematic I'm going to give you is going to be the one where we solve for velocity final squared. The velocity final squared equation equals velocity initial squared plus 2a, so 2 times your acceleration, times your change in distance. Now remember, change in distance, another way to write that would be our distance final minus our distance initial. So either way you see it, that's fine. Not a big deal. You should be able to plug, when you see this, you should be able to plug that in and be able to do your equation. Okay. Again, pitfalls we're going to see on this, obviously, when we square. Okay, we forget to square. We forget to take the square roots. Other things we do when we're rearranging the equation, I see a lot of times when they want to get rid of this, they want to, let's say they're solving for acceleration. When they solve for acceleration, they want to get rid of your velocity. You bring the velocity over, but for whatever reason, you think you want to divide. Remember, addition, do the opposite sign. Make sure you subtract. That's a big problem. Don't know what it is. It's pretty easy math, but we'll be working on that quite a bit throughout the year. Okay, those are your kinematics. Again, make sure that the basic kinematic equations are in your notebooks. You should be able to rearrange from there. Guys, good luck with these. You'll be seeing them a lot.